Hello and good morning, everyone. Hope you're all doing well. Welcome back to FE Review Online Edition. This is the mechanical section, and this is Nicholas, who will be guiding you through some problems in mathematics today. If some of you may have seen already that the materials that were sent to you also included some linear algebra and geometry. We will not be going over those today. We will be focusing mainly on the calculus section. You may take a look at the rest of the problems in those other two sections and answer accordingly. So, specifically for today, we will be looking at problems 3, 4, 5, 6, 8, and 10. So hopefully you find this useful. Since calculus, a lot of you may have taken that like a couple years ago. Calculus 1 being all the way back from like your maybe first, second semesters in university. So we're going to try and shed some light on those old memories. Okay then. We're going to be starting on problem number 3 of the mechanical practice section. And we're going to be asked, what is the approximate area bounded by the curves y equals 8 minus x squared and y equals negative 2 plus x squared? Okay. We have two equations. Area bound between y equals 8 minus x squared and y equals negative 2 plus x squared. Some of you may already know how to do this immediately, and that's fine. That's great, actually. So we want to find the area bounded by the two curves. To do this, let us equate these two equations. Negative 2 plus x squared equals 8 minus x squared. And now let's solve for x. X is going to be equal to plus or minus square root of 5 if you do some algebra. Alright, so now what does this mean? We now are going to have to, I think it'd be easier if we drew a picture of this. So, let's use a different color. What is going on right here? So we have our y-axis, x-axis. Both of these equations, one of them is a parabola, the other is an inverted parabola. So we have one, it reaches about here, so let's say. And another one with an intercept of what, 8, yeah. Negative 2, then positive 8. All right. So we have 2 points of intersect, one here and one here. Those values are the minus radical 5 and plus radical 5. So with this, we can see where our two functions are meeting. So we want this area here. Looks like a circle, isn't it? But it's not quite a circle. What we're gonna do is take two integrals. We have f1 of x and f2 of x. Let's call this f1, this f2. So we know that the integral of one of these will give us the entire area under each of these curves from specific points, depending on what points you're doing. So if we want the area that's in between these, we need to take one subtracted by the other. And we can do it between the two bounds that we have here, negative radical 5 and radical 5. With that, we should be able to get the area that's in between these two curves. So let's call this area equal to the square root, the integral of negative radical 5 to radical 5. We have f1, which is going to be 8 minus x squared minus, and this is negative 2 plus x squared. I can barely see that. We're on the next line. Apologies for not having a lot of room here. Minus negative 2 plus x squared dx. So let's do some algebra and simplify this a little bit. It's going to be what? 10 minus 2x squared dx. So if we continue this integral, we're going to get 10x minus 2/3 x cubed. Evaluated at negative radical 5 and radical 5. All right, so now this is going to give us 10 radical 5 minus 2/3 radical 5 cubed minus 10 times negative radical 5 minus, well, let me put some parentheses here. 2/3 times negative radical 5 cubed. Okay. So we do some algebra here. What we come out with is around 29.8, which is most closely related to the answer choice corresponding to 30, which is C. Awesome. There's our first problem of the day. Getting some finding the area between two curves. No matter what they are, you can find that if you have some boundary condition and two functions. You can subtract the two functions between the boundary conditions you're looking at and get your area. All right. Let us move on to our next problem, which will be number 4. I forgot to write the number on the past one. That's okay. Number 4. We are being asked that's the wrong section. Oh, here it is. What are the minimum and maximum values, respectively, of the equation f of x equals min and max of 5x cubed minus 2x squared plus 1 on the interval negative 2, 2. Okay, so we're going to be min-maxing this, which, if you were with me on the first session for FE, we did a min-max problem. It basically is the way that you would do it is to take a derivative of our function here, set it equal to 0, so we can find out where the peaks of our graph are going to be. When our derivative is 0, we can determine where our maxes or mins will be. So for this one in particular, let us do just that. What is the first derivative of 5x cubed minus 2x squared plus 1? That's 15x squared minus 4x equals 0. All right, let's see if we can solve for x now. X is going to be equal to 0 or 4/15. So that gets our two critical points. Which will help us in doing our second derivative test, which will help us find the min-max or inflection. All right, so let's do our second derivative. Derivative of this now will be 30x minus 4. Right. Okay, so with this, let's plug in our first critical point. What do we get from that? If we plug in x equals 0, we get -4 equals f double prime of 0. So let's circle this. Let me write this the other way. Nope. Equals -4. Okay. There's 1. And now let's do 30x minus 4, where x is equal to 4/15. Now what do we get? -4 equals 0. This is going to be 6 minus 4? No. 8 minus 4. Which is +4. So we have f double prime of 4/15 is going to be equal to +4. All right, so now we got to determine which one of these is our maximum, which one is our minimum. If we look at whether this is greater than or less than our f of a. Where am I going to write this? Right here. So f double prime of a. This is less than 0. So if you remember from calculus, if your solution for your second derivative test is negative, meaning less than 0, you have a maximum. It's a little counterintuitive. It's kind of the opposite of what you'd think it would be. And then since this one is greater than 0, this will be a minimum. So you're greater than 0, you get a minimum. You're less than 0, you get a maximum. So that would be the two descriptions of our maximums. Though we don't know if they are local or global. So we got to do a little bit of extra work here to figure that out. So what we got to do now is check the endpoints of our interval and compare that with the function values at the critical points. So let's do that. me go back to orange. We have f of -2. Sorry, this is, if you remember, -2 and 2 is our interval. So we're using that. This is going to equal 5 times -2 cubed minus 2 times -2 squared plus 1 equals -47. Okay, so now let's check f of 2. This is 5 times 2 cubed minus 2 times 2 squared plus 1, that's 33. All right, so we have those two. So now let's check the two values 4/15 and 0 as endpoints and see what we get from those. F of 0, that's going to equal, or let's do 5 times 0 cubed minus 2 times 0 cubed plus 1, which is equal to just 1. Now f of 4/15. 5 times 4/15 cubed minus 2 times 4/15 squared plus 1. I'm going to skip the algebra here and say this is equal to 0.95. Okay, excuse me. All right, so now what does this tell us? These two values for our critical points give us 1 and 0.95, where our others give us a very large negative number and a very large positive number. So since those endpoints are the function defined at the endpoint, or at the endpoints -2 and 2 are much larger, our two mins and maxes are going to be at those endpoints because they're being defined inside the two endpoints, and the function evaluation is less than, or I shouldn't say less than, it's in between 47 and 33. We have 1 and 0.95 are both in between 47 and 33. So we know that they are contained between the two endpoints. So in that we can call them local mins and maxes, since we don't have the rest of the function. They're local within their respective bounds, -2 and 2, though since they are going to be the only ones there, we could call them the global min and max as well. So the answer choice wants us to say, we want to know what are the values of the equation on the interval. Oh, sorry, what are the min and maximum values of the equation? So those two numbers are going to be -47 and 33, which actually are the endpoints. That's what I was saying earlier. Not to be confused with the solutions for this and this. This is just to help us find out, are our critical points going to be considered mins or maxes, or are mins and maxes going to be at the endpoints? They just so happen to be at the endpoints. These numbers are much larger than these, as you can see. So our answer choice will be defaulted to A. Cool. All right, let's move on real quick to problem number 5. It's a little bit of a conceptual one. Okay, so in vector calculus, I want you all to think about this. If you guys can see the problems too, that's great. I don't have to write as much down. I'm gonna try and paraphrase here. In vector calculus, a gradient is what? Now we have four choices. We have a vector that points in the direction of a general rate of change. Direction of rate of change. We have vector that points in the direction of the maximum rate of change. Sorry, the first one was points in the direction of a general rate of change of a scalar field. Where number two says is points in the direction to maximum rate of change of scalar field. Number three, a scalar that indicates the magnitude of the rate of change of a vector field in a general direction. Magnitude of rate of change of vector field in a general direction. And four, a scalar that indicates the magnitude of the rate of change, or indicates the maximum magnitude of the rate of change of a vector field in any particular direction. All right, so our different choices here, we have A is I only, B is, A is 1 only, B is 2 only, C is 1 and 3, and D is 2 and 4. Okay, so right off the bat we can see that 1 and 2 say very similar things with very small difference. We have a general rate of change and a maximum rate of change. So we know that both of those can't be the correct answer, and 3 and 4 also says a very similar thing. So we know that neither of those can go together. Unfortunately, we can't eliminate any answer choices right off the bat because of that, since none of them give us that. So we need to figure out, can we have both something like this be true, like number 1, as well as something like number 3? Can something indicate the magnitude of a rate of change of a vector field in a general direction while also pointing in the direction of the ROC of a scalar field? Can it do both those things at the same time? Well, if you know what the definition of the gradient vector is, this should be a pretty easy question, but if not, we're just trying to go over some skills you could employ to kind of get the correct answer, even if you don't know what a vector field is, or a gradient vector is. So the definition of a gradient vector, I'll give it to you right now, is at some point P is described by use of the gradient, which is the del symbol, function fp dot a, where a is a unit vector in a 3-dimensional rectangular coordinates The gradient is equivalent to the partial derivative vector. If you guys are familiar, in the I direction, J direction, and K direction. This is a vector that points in the direction of the maximum rate of change, also known as the maximum slope. So, that being said, the only one of the answer choices that was talking about maximum slope only, maximum rate of change. That's number 2. And it's not the magnitude. It's, it is towards the rate of change. So the answer for this would be B. We're going to go over a gradient problem later. I believe that's number 10. So we'll go over that in even more detail. So let's quickly move on to number 6. Okay, it's another one. I'm not going to completely write this one down. Okay, we have which illustration shown represents the vector field f of xy equals negative yi plus xj. We need to figure out what is this going to look like. So we have our y term is negative in the x direction. Okay. Let's look at the answer choices really quick. Okay. All right, so our y is a negative term and our x is a positive term. Maybe I should write up. Okay. This would be easier to explain if I just write all the answer choices out. So A has this. And B has this. C has this. D is an interesting one. Okay, cool, we can see them all. So based on what our first piece of information is, we know that y is negative in the I direction. Negative yi. So for this one, we have the y portion of this field in the I direction, which is along the x-axis, is going in the positive direction on the left side of the y-axis, and it is going, right on the right side of the axis it's going positive, and the left side of the axis is going negative. So we know that this one cannot be correct because of that. So we continue on looking. I guess actually let us instead try and determine what properties our vector field has to have if we have a negative y in the I. me go down here. So if we have this, positive values of y, for positive values of y, the field has to go to the left, correct? So if you put in a positive 1 in there, you're going to have a negative 1i, which is going to be to the negative x-axis. And then we also know that negative values is going to point to the right. Okay, so that's cool for that. Now let's look at x. For x, positive values will point up, and negative values will point down. So with that information, let's see if we can discern which one of these is correct. So for positive values of y, we're going to point to the left. Which one is true? It's left. So on the top, we have to have both of our vector directions pointing to the left. That is not true here. It is also not true here. And it is also not true here. So just from that, we can determine this looks like it's going to be a very nice answer, but let's be sure. So when y is a negative, it's going to point to the right. Again, it's only true really for the case of C. For x, positive value is x, we're going to point up. Both of these are pointing up. Negative values are pointing down. Both of these are pointing down for negative values. So it looks like our correct answer choice is going to be C, which is the correct answer. It could be tempting to put B, seeing as you have a similar circular pattern, but it is not correct because this is not pointing, this and this are not pointing in the correct directions to make this whole entire statement true. Awesome. Hopefully we all understood that. We're running a little low on time, so we're going to move on to the next problem, number 8. Number 8 is a simple integral. I shouldn't say simple, but it is an integral nonetheless. What is this? This is an indefinite integral of x cubed plus x plus 4 divided by x squared. Some of you may look at this and be like, oh no, quotient rule. How am I going to do this? But we don't need to use quotient rule, actually. What we're going to do is we're going to separate this like this and do it like that, because we have a lot of cancellation go on. So instead it's just going to be the integral of x plus 1 over x plus 4 over x squared. Okay, I'm pretty sure we all can do an integral similar to this. But just in case we cannot, let us go over what we should do for each piece. So first piece, x, integral of x. We're doing our nifty calculus shortcuts and whatnot. We're going to have 1/2 x squared. That's what we get from that, plus natural log of x plus 4 times 1 over x, negative 1 over x, plus c, can't forget the c. So to simplify, this is going to be x squared over 2 plus natural log of x minus 4 over x plus c. This is answer choice D. Awesome. All right, let's move on to our last problem, number 10, which is a gradient problem. All right. The direction of the line passing through 1, -2, where the maximum slope is found by inserting x equals 1 and y equals 2. This is our x, this is our y. The specific problem is asking us for, we are given f of x, y, 2x squared minus y squared. I'll write this down here. 2x squared minus y squared plus 3x minus y. What is the slope, what is the direction of the line passing through the point 1, 2? That has the maximum slope. We just saw in our previous problem that the gradient points in the direction of the maximum slope, or the maximum rate of change. So what we want to do here is we're going to take the gradient of this above function, partial f partial x plus partial f partial y plus partial f partial z. What are we going to get from doing this? Okay, so we're going to take a partial derivative with respect to x first. We're going to have, what is it, 4x minus plus 3 minus y. That's going to be in our I. And then the partial y, there is no z, so this term will drop out to 0. Two x squared minus 2y. Oh, my bad. That's not correct. It's going to be actually just 4x plus 3. I forgot the, when you do the partial derivative, the y terms will also drop. And then for the j direction, we're going to have 2y plus 1. Though this will be negative. So our total thing we're going to equal is 4x plus 3, I minus 2y plus 1, j. So now what we want to do is plug in the two boundary conditions that we were given into this, and we'll be able to get the direction of the line. And this is, if you guys are not familiar, this is going to be imaginary real axis, since we have, sorry, forget everything I just said. I in as in the x direction, j is in the y direction. I guess you can look at it as an imaginary and real axis if you wanted to, but we don't need to do that. So at 1 and -2, the gradient will be defined as 4 times 1, 4 times 1 plus 3. It is going to be 7. I. And now negative 2 times 2. Negative 2 plus 1. That's going to be negative positive 4 plus positive 4 minus 1. Distribute our negative sign. It's going to be a positive 3j. That is the direction of the line passing through those specific points. And this is most directly correlating to answer choice B on your problem. All right. Well, I will have to say again, thank you all for joining me on this little adventure through some FE problems. Hopefully you got a little something out of this. I know the topic was a little simpler this time, but I'm trying to get on a more routine schedule of how we're going to go through our FE book. So I decided to position at the very beginning, and we're going to go from there. If you guys have any suggestions on what you want to go over, let me know. I'll make sure to include that. I should have comments in the below section now, so you can put comments on. It was my bad. I was setting up the videos incorrectly, but that should be fixed now. So as always, leave a like if you thought this was useful, or not. That's fine too. Post in the comments if you have some questions. I'll look at them when I get a chance. And yeah, I hope this was helpful. I wish you all the best, and good luck.